Thank you everybody for joining our second BGSS webinar as part of Leeds Digital Festival. This one is The Road to Better Data, a Highways England Ontology. Now we are recording today's session, so if you do miss any of it or have to leave, don't worry, we'll be following on. And any questions that you have, please do send through the Q&A functionality. So without further ado, I'd like to hand over to Ocean and Neves for today's session.
Thank you. Thanks. Yeah, hi, so my name's Ocean. I'm a data engineer at BGSS. From December last year to May this year, I was doing data modeling with Highways England to create an ontology, which we'll talk about in a second.
Yeah, hi, I'm Neves. I'm a business and data analyst. So as Ocean said, I've been also working at Highways England project. So I've been participating in the first phase of building the ontology model, and now I'm really using the ontology model in the next stages. So we will go further in detail.
So we'll broadly split the presentation in two. I'll give the first half and the others will give the second half. I'll be talking to you about who Highways England are, what they do, a bit about the project that we were working on. Then of course get straight into what actually is an ontology. Kind of as a spoiler, it's a model of the organization. Then we'll walk through a kind of small sample ontology to try and get the key points across. And then we'll talk about what's the point, why are we doing this? And again, kind of spoiler alert, the main reasons are to inform our data structures and to bring about a consistent naming within the organization.
Yes, and in the second half, I will use all the knowledge that Ocean will explain to us to do an ontology model, to explain how to build it and when should we start it. So it will be a bit more demo part.
It's important to note that this is supposed to be kind of more interactive. A lot of these concepts will probably be new. We might use some language that's a bit unfamiliar. So if you have any questions, please just ask them and we'll answer them later on. So without further ado, for Highways England. So Highways England are a government organisation. They manage and maintain all of the major A roads and motorways in England. So they don't deal with Scotland, Northern Ireland or Wales. They don't deal with the roads around your house, so don't blame them on any of your potholes. They actually only manage about 2% of the roads in England, but those 2% of roads carry 66% of the heavy goods traffic in the UK and 33% of all of the traffic in the UK. So they're a kind of major backbone of the UK's transport infrastructure. They're also quite a large organisation in terms of the funding they get from the government. They work in 5-year funding cycles. The last one finished in March and the new one started in April. So the funding cycle they got for the next 5 years is I think 27.3 billion to improve the motorways and the major areas of England. So the project, when I was on it, so this was back in kind of February, March time, early this year. At that point in time, we had about 50 BGSS staff and 4 of us were doing data modeling. The whole aim of the project is to create a data as a service platform. Highways England used to be something called the Highways Agency. They changed the name. And before that, they were a set of kind of disparate organizations or teams. And they've kind of been pulled together under one umbrella organization. But they still don't necessarily interact as a consistent unit. So there's still lots of the teams are very siloed. And it means that the data that those teams hold is also siloed within those teams. So not only within the teams, but between different business areas. So the idea of a data as a service platform is to kind of consolidate and bring all of that data into one place to try and be able to link up data in different ways, reduce the duplication of data, reduce the duplication of effort to analyze the data, and to basically get more value out of the data. So that's what the data as a service platform is supposed to do, and the ontology is supposed to help with that. And I'll talk about why now. So what actually is an ontology? I'll come straight out with the definition that I normally give, which is it's a representation of everything that exists and how those things interact. So I'll say that again. It's a representation of everything that exists. So for us, we're interested in everything that exists in Highways England and everything that Highways England interacts with as well. So including their stakeholders, government organizations and suppliers, people like BGSS, and how those different parts within the organization, how those different things interact with one another. Ontologies really have their foundation in academia. They're normally used in the biological and medical sciences to systematically and categorically structure the way you're looking at diseases or viruses or anything like that, so that you make sure you cover every possible route and you've encompassed every possible way of doing the investigation. They're not seen as much in the corporate world because there's a lot of this kind of academic terminology and jargon around it. It's kind of difficult to break in there. So I will be using, hopefully, mostly normal words, but there are a few words that I'll need to introduce to you. So this is what an ontology looks like. This is a kind of a small dummy ontology. This was actually meant as a kind of half joke. It's a coffee ontology, so I got it printed on some coffee mugs. But it's actually a good explanation of what an ontology is and kind of why it would be useful. The reason I'm showing you this one as opposed to the Highways England one right now is, well, this is the Highways England one. If we go back to the coffee ontology, you'll see there are maybe 15 different entities, these things that exist, like a person and some food and your coffee. And there are maybe 10 types of relationships connecting them all. The Highways England ontology, as it currently stands, has over 200 different things that exist, 200 entities, over 60 types of relationships, and 300 instances of those relationships connecting all the entities. So it's very difficult to kind of see what's going on and understand. And even when you zoom in, it's still very unclear what's going on. Visualization is another problem you have when you get large ontologies, which we'll touch upon later. So anyway, going back to our coffee ontology. The first thing we should look at is the key. To explain what this is showing, we need to think about what an ontology is trying to do. So what we're trying to do is we're trying to categorize everything that exists. So we start off and we think everything that exists, we kind of categorize it as a thing, and then we split up all the different types of things into different categories. We've chosen a kind of a standard approach, which splits the world into 3 types of things. And there are these three things in the circles here. So first of all, we have material things. So these are normally physical things you can touch. So like I can knock on my desk and it's a physical thing, I can pick it up. You have immaterial things. These are more like concepts. So you can think of a material thing is me, Ocean, as a person. You can touch me, you can poke me, I'm made of atoms. And an immaterial thing would be the role that I'm doing. So Ocean as a person is performing the role of data engineer. You can't pick up the concept of a data engineer and poke it. It's kind of like a concept that a person is performing or doing. Other examples of immaterial things are like corporate structures. Like you can't pick up your management structure, but it still exists, it's a concept. And finally, occurrence. So these are normally events or things that happen. They're normally time bound. So an example might be me spilling my water would be an occurrence, an event. Highways England specifically, an occurrence might be a crash or a flood. So yeah, we take everything in the universe and we split it up into these 3 things. So that should make this diagram make a little bit more sense. You can kind of see how we're categorizing all the different things into these 3 different types of things. And then we describe how these things interact with these lines with relationships. So if we zoom into just this section at the top here, is what I'll be talking about. And I'll walk you through a quick example. Now, coffee ontology might seem a bit simple to most people because we all know how to make coffee. So while I'm talking you through this, I want you to think about 2 things. Firstly, imagine you're maybe a coffee house like Starbucks. Imagine you've grown by acquiring different franchises. Those franchises will serve different types of coffee, different types of drinks. They'll be made in different ways by different coffee machines or different pieces of technology. You'll have employees with different skill sets, being able to make different types of coffee, and you'll maybe use or buy your coffee from different suppliers. And this extends beyond coffee to tea and hot chocolate and whatever. So you have, imagine this organization that's kind of come about as a kind of conglomeration of smaller different organizations that were storing all of this information. Now, these organizations would have probably been storing their information in different ways, different formats. They'd be using different words to describe the things. So when you come to consolidate all that information, how do you do it? You need to kind of decide a single source of truth. You need to decide what word you're going to use to describe the liquids that you sell, coffee, tea, hot chocolate. You need a way of structuring the data that you store about your different coffee machines and the different skill levels required and who has those skill levels. So that's one example I want you to think of. The second one is, imagine you're an alien coming to this planet for the first time. You don't know what coffee is. You don't know how to make it, definitely. And you want to kind of understand how it all works. So what you do is you get a diagram like this, and you can see that the role of coffee maker is performed by a person, and that person operates a bit of technology, an example of which is a coffee machine, in order to prepare your drink and get a final output of your composite liquid, which is your coffee or your tea or your hot chocolate. The alien example might sound a bit weird because, yeah, aliens coming to England and looking for coffee, it seems a bit bizarre. But imagine if you're starting a new company or going into a new role in a new part of the company that you don't know. There's often a lot of new jargon that you don't understand or aren't familiar with. You don't know what relationships exist between people. You don't know how the business flows work. And as someone who's kind of started in two different capacities in two different parts of organizations in the last year, I know that it takes a while to kind of ramp up your understanding of the jargon that exists and to understand the processes that go on within your business area. So one of the areas that a diagram like this can help you with is firstly to understand what exists in your organization, especially if a diagram like this includes all of the different possible relationships that do exist. And it kind of allows you to settle in and know what everyone's talking about and know what's happening a bit better. So I kind of just alluded to talking you through, you have a physical person performs a role of maybe barista that operates a piece of technology like a coffee machine to prepare a drink, e.g. coffee. You have another thing that exists. The coffee house might sell cookies or a biscuit. Those biscuits get dunked into the composite liquid. Both get consumed, again, by another person. This time a different type of person. That'll be a customer rather than an employee. But that's something that would probably be stored in later on down the line in actual physical data models. So that's a kind of quick run through of what an ontology is kind of doing and how it's stored and the kind of information it is storing and representing and showing. So what's the point? I've kind of alluded to a few of these. The biggest thing to probably say is that the main point is to improve efficiency, reduce the duplication of effort, improve the quality of your data, improve understanding within your organization, save time, and eventually save money. It's very difficult to put a number on how much money is saved, for example, because a lot of these benefits are kind of secondary benefits. What you're doing is, for example, reducing the time that a data scientist has to trawl through different documents that they can find or email people who wrote different pieces of code to understand what the column in one table of data means because it's not clearly labeled. You're reducing that time by kind of giving them a source of truth where they can look to see what that data is relating to and save them time here and there. So it's a lot of the benefits are kind of secondary rather than like primary direct cost saving benefits. So it is difficult to put a number on, but I'll walk you through some of the key ones. Now these are 11 points, which are the kind of main points where an ontology is useful. We've split them out into business cases on the left and data cases on the right, because it's kind of equally applicable to business users and data users. And what I'll do is I'll walk through these ones very quickly, because the main 2 points are common terminology and informing data model structures, which I have on later slides and we'll go through in more detail. So common terminology. The idea of having a common terminology is that you want your teams to be able to use the same language to talk about the same thing. In Highways England, I already said that they're quite siloed in the way they're structured, trying to become more integrated now, which is great. But because these teams kind of grew up independent of each other, they've evolved their own terminology and their own way of talking about things. So 2 teams might use the same word to describe different things, and they also might use 2 different words to describe the same thing. So when you're, for example, when you have one team handing over a project to another team, it can become very difficult to understand what they're talking about. If I say one word and you think it means something else, and I say another word and you think you know what I'm talking about, but actually I'm talking about something different. So common terminology. This is applicable to both business and data cases as well, because if you don't know what the column names in your tables mean when you're analyzing your data, you don't know what the data means. So yeah, you can't understand the data properly. Starting a new project, role, or company. So this is the alien example. Basically, you join a new organization or a new team, or number 4 is high-level company structure. So if you're high-level management, for example, understanding how your role fits into the organization, understanding how your team fits into the organization, understanding how your project interacts with other projects and other teams, all of that is very important information to store. And the ontology gives you one place to store all of this and hopefully display it in a nice way that helps you understand it better. Third-party suppliers. So this is along the same lines. Highways England being a government organization, they do use a lot of third-party suppliers. And the third-party suppliers come in and have their own terminology for things as well, which gets mixed up with the Highways England terminology, and then things get even more confusing and complicated. It would be better if third-party suppliers coming in had to conform to the Highways England words and jargon that the Highways England employees understand and know and have developed. And the ontology gives you a place to say, okay, third-party suppliers, you're supposed to use these words. And this is how your role fits into the organization as well. Finally, synonyms. So these teams have evolved their different terminologies, the different words for the same thing over a period of years, and they're not just going to disappear overnight. So it is important to understand where these differences in communication are happening and have a place to store them, so that when these teams are communicating, you might say, oh, they said this, I'm not entirely sure what they mean. You can look it up, search for synonyms for it, and then hopefully find out that it's a synonym of something, another word that you do understand because it's a different word in your team. So those are the business cases. The data cases, informing logical and physical data models. So this is pretty much about taking your understanding of the organization's structure and the understanding of how the different teams in that organization work and the jobs that they do, and you translate that directly into your relational database table structure. So the names of the tables, the names of the columns in the tables, and the way that the different tables are linked up should be based on the ontology. So when you're bringing together different bits of information from different parts of the organization that may be kind of related and similar, you can structure it in a consistent manner so that you can more easily analyze it later. And you end up, rather than bringing all your data in and kind of just throwing it in and ending up with a data swamp, you do actually get a kind of nice clean data lake where your information is structured nicely and you can generate the best insights from your data and get the most value from it. One of the big reasons to have an ontology that I think Highways England is interested in at the moment is something called a digital twin. So digital twins are kind of simulated duplicates of your physical infrastructure or physical world. And the idea is that you can simulate what would happen if something went wrong with the network. So an example of a digital twin is the Met Office. They have a digital twin of Earth, which they use to predict the weather. So it's a model of the Earth. It's a kind of a digital, a simulated computational replica that they use to simulate situations to try and predict the weather. The idea in the future would be to have these kind of digital twins of all the different types of infrastructure within the UK. So all the transport infrastructure within the UK, I should say. So the roads, the trains, air travel, pedestrian, potentially. And you would have these different digital twin models held by different companies that would then be able to interact. So you could simulate things like a football match. So you have however many thousands of people congregating in one place and they all disperse at once. You can simulate the road on the network, but not just the road network, the train network and the tram network, depending on where you are. And you can see where best to divert traffic so that you reduce overall effect on the network. So there's an organization called the Centre for Digitally Built Britain, who are kind of championing and pushing forward the idea of digital twins at the moment. And they released a white paper recently where they suggest that the foundation for a digital twin model should be an ontology of that organization. So that's where the ontology can help as well. I'll go through the rest of these quite quickly. Gap analysis. So the idea is that if you have two teams doing similar things, they'll hold data on similar pieces of data. So you might actually have two teams which they have like overlapping data. And first of all, you're kind of wasting team effort by understanding that the same piece of data twice. It would be better for one of the teams to focus their effort on understanding a different piece of data, so you get an overall benefit. You also might have two teams where they overlap in data, but then also have a gap in the data somewhere else. So it would be better to shift the focus from places where you have duplicated pieces of data to places where you're currently not recording data. So understanding what data is there, where it overlaps and where there are gaps, so you can improve your overall data quality. Data location, this is implementation dependent on how you actually go about using your ontology. So currently Highways England will have data stored in lots of different locations. So they'll have some in the cloud, some in on-premises data structures, data centers. They'll have some in data centers which are managed by suppliers, and the list goes on. So just understanding where that is and trying to kind of consolidate it better. Ontologies can be used as schemas for graph databases. So if you want to do some sort of semantic querying, you can use the ontology as a kind of base to create the knowledge graphs. And interconnected web of data. So this is more about when your organization becomes quite large and you have teams publishing data for the rest of the organization to use, you can often lose track of who's using your data. And that means when the team that was originally starting to publish the data maybe doesn't need that data themselves anymore, or they want to make a schema change, or they want to remove part of data or something like that. If they change it without knowing where the data is being used, they can break someone else's system further down the line without even knowing it. So just having a better knowledge of how your data is interconnected within your organization, understanding who is using your data is important. So a little bit more in depth and some more concrete examples. So these are business use cases. So I was talking about understanding where your role sits in an organization. So the bottom left diagram is the same ontology diagram of Highways England that I showed you earlier, except we filtered it down to only show entities related to the maintenance part of the business, and specifically only related to performance, condition, and risk, because those are the three key considerations that Highways England takes when they're doing any maintenance project. So this is effectively a diagram of the key considerations that the maintenance department have to interact with and consider when they're doing any kind of project. And you can get this just by taking your entire ontology and adding various filters to it. And I can see, for example, that my performance is monitored by a role. Risk has to also be managed by different roles. The maintenance of an asset is triggered by the condition of the asset. Once the condition of the asset goes down, then it triggers someone to do maintenance. So diagrams like this kind of show you where your role sits in the organization, but if you also click on one of these entities, at the top here, you can see you get a list of all the different business areas that entity relates to. So you can potentially click on these and understand what other parts of the business your project might be affecting. On the right, we have a search feature. So this is talking about synonyms or words that you want to know a definition for. You can just search the entire ontology for them. So for example, strategic road network asset. When you click on that, you get all the information to do with that asset, including the definition, what business areas it relates to, the subdomain. So you can also, like, what part of the construction it relates to, and you can store a lot of other information, like, for example, what data set holds information about this particular entity. And of course, the relationships that this entity has with other entities. Data use cases. So here's another example of the ontology filtered differently this time. So now it's just showing information to do with geographical information. So you can see we have land, for example, and we have a polygon in the top right, which is one of the data structures that you use to represent your land digitally. And the data use cases that you use this structure, all of these entity names, to inform your relational database table structure. So here you can see, very importantly, land is the same name as land here, and all of these column names will be inspired by the ontology's name. The structure of these, the way that these relational database tables are linked, is also inspired by the ontology and should follow it as closely as it can. There are some exceptions, of course. So an example is here, is role, which in the relational database is represented as a responsibility. And it's represented as responsibility because role is a protected attribute in SQL, so you can't use it as a table name. Instead, what you do is you, every entity that exists within the ontology has a unique identifier, so like a unique string of characters that identifies that one entity uniquely. And what you do is you link that to a table or a column name just by saving the unique identifier. And what you can do later on, once you have your data structure saved, if you don't know what a particular column name or table name is related to, you can go and look up the unique identifier, go to your ontology, search for it, and find out what that piece of information is about and the definition, how it relates to other parts of the organization. So those were use cases for the ontology. I'll now pass on to Nieves to talk about how you build an ontology.
Thank you, Ocean. So yeah, assuming that there is no alien in the call, but maybe there is somebody with a new coffee machine, who knows? Yeah, so Ocean just explained everything that is related to the ontology model. Maybe you say, it can be useful for me, but how should I start with it? How should I build it? So let me show you our process, how we followed it. So I will share this presentation. Perfect. So yeah, the first question is, when should I build it? When is the best moment to build it? So it depends, of course. We cannot decide always. So for example, on our side, we were quite lucky because in Highways England, they are trying to do a digital transformation. They are trying to change the way the data is structured. So the first step was really to build this ontology model, which is quite useful because we had time to discover how Highways England business is working, but also we have time to build this ontology model, so it will be the base for the further data sets, data models that we will be creating. So yeah, I would say that the best moment is to build it before the data models are created, but I understand that this is quite difficult. So yeah, it can be started at any time in a life cycle of a company, but indeed, I think the best point is to start with the ontology model. So how do we start it? What do we do? I mean, yeah, we know that an ontology model, it's split in things. Then we have material, immaterial, and occurrent things, but there are so many things in the company. So what we've done, we've been checking first internally within BJSS with different experts, and all of them, they all suggested to really understand business, understand the company, understand business flows. So I think it's a really good point to start. You need to have a global view of how the company works, but also how the company interacts, how the teams interact between them. So yeah, mainly the first steps, the first weeks will really be to investigate how business works. So How do you do that? Of course, you need to talk with people, you need to identify stakeholders, you need to even search in Google. You have a lot of information in there also. So yeah, in our case, Highways England has to publish a lot of information. So we found a lot of documents to read. And then there was something interesting that we had. Let me share it. Yeah, so this is a diagram. This is the Highways England diagram of how they are working. So if you can see in here, we have different business areas. So plan, operate, maintain, construct, and design. So these are different business areas involved in different projects for the highways constructions, maintenance, operations, and so on. And then there is a unique point of trust, a unique point where all the data is in there. And then we can easily connect with customers, with the physical assets, and with the data. So if we zoom in a bit, we have much more detail. But in the center, we have all the data life cycle. So specify, collect, collate, evaluate. So yeah, the idea is that what we are seeing here is that Highways England is a very centralized company with all the business areas interconnected and using the same data. However, this is the future. Currently, this is what we have. So if I zoom out a bit, as Ocean mentioned, Highways England was composed of different companies in the past, so it's normal that data is quite siloed. So there are different business areas that are not connected, that they are not using the same data. They are using the same data, but duplicated. They don't know that other people are using the same data. So this is part of our digital transformation project. And this is why the ontology model was really helpful. So what we've done is we focus on the first 5 big business areas, which are operate, maintain, construct, design, and plan. And well, we were 4 modelers. So we mainly split it 1 business area per modeler in the beginning. So, okay, we knew what to do. So now how do we do it? So yeah, what we've done, you need to understand, for example, imagine you have to do construct business area, you need to understand how it works. So if we zoom in a bit, we see that there are, I will put the future one, which is a bit more easy to understand. We can see that there are a lot of items and entities impacted in the construct. We have a construct supply chain, meaning that we also have stakeholders, we have materials, we have assets, but also these entities are used in other business areas. So mainly what we've done, for example, before analyzing a business area, try to understand how is it, try to find all the information, and then discuss with the stakeholders of that business area. Normally there are multiple stakeholders because this is a business area composed of a lot of small teams. So we try to understand, and the easiest thing is really to create a list of entities. So for example, for construct, we just create a list with supply chain, materials, stakeholders, schedule for the construction, plan, project, budget. So a different list of entities. And then we try to create a small ontology model. So for this, we have used Draw.io. So Draw.io is a free web app where we can model different diagrams. So why we are using this? Because we wanted to isolate the business areas in the beginning. We wanted to work individually, each modeler. So trying to model in here, so based in the material, immaterial, and current entities, we try to put all the list of entities that we have first gather in here. So add all the relationships between them. So this is our first draft of our ontology model for a specific business area. Until here, it seems quite okay. Now is the moment to come back to business and say, okay, we've been discussing with all this audience, with all these people, with all these teams, and this is what we found out in the construct business area. Is this correct? No. So this is a very iterative process. We need to come back again, discuss again about the model, because there are things that we didn't understand correctly, or maybe they don't like the way we are using the terminology that we are using, or maybe the relationships are not clear. So this is really a work to be done with the client constantly, because they are the ones that really knows how business works. Because yeah, we can read a lot, but we are not working really every day with them. So it's really an iterative process, face-to-face with the client continuously. So, okay, now we know, imagine that the construct business area is model. I think it's okay. So for example, here I have other tabs for the communicate, for handover, for the project life cycle. So we have different small ontology models. So if I come back to the presentation, okay, we have split it in different chunks, okay? And then we are in the iterative process. So we have the documentation, we have used Draw.io, and we have discussed with stakeholders. We are happy. We can see that the diagram is complete. So the next step is really to discuss with the rest of the modelers of my team and say, okay, what do we have? What do we have in here? Do you also have it in your business area? It's the same terminology. So it's really a process of going one by one, explaining the model. So yes, with the diagram that I show you, for example, in the Draw.io tool, just go by one saying, okay, this for me means this. I have this relationship because these reasons. So other people will say, I also have this, for example, construct and maintenance business areas are quite related, for example, or operations are quite related. So there were a lot of overlapping, which was really interesting because this is one of the purposes of ontology, to find the overlapping between teams, to find where the data is used again between different teams. So we were able to mark for each entity the different business areas impacted, the type of data using that entity, and then we integrate it into the big diagram, okay? So when integrating in the diagram, we will always have cases, entities that exist with different names. So at that moment, we need to either find synonyms or try to find an agreement. So this is not up to us, it's up to the final user. So we came back multiple times to the users to try to see, for example, we have a case where for the operations team, the event, it's really, for example, a football match, because they have to make sure that the traffic will be maybe crowded in some places of the city. So they have to make sure that other roads are available and so on, that there are no works going on that area, for example. So this is an event for them. For other teams, an event is an incident, it's an accident in the road. So that's really the purpose of ontology. One of the, after using it, after 1 year using it within Highways England, we've seen that this is one of the best points we have of having an ontology model, because the users are really happy with this. They understand what we mean. There is a description near each entity. So it's really an agreement across multiple business areas. So let me show you the model that we have created. So as Ocean mentioned in the beginning, the visualization was quite complex. So there are not a lot of, or we were not able to find a lot of good tools to define ontology. So it's true that there are a lot of tools, but they, the way to navigate from one entity to another is not that easy. So for example, here I have filtered out, we are using Web Protege, okay, which is a open source stand for university software. So here, for example, I have filtered out. So this is mainly the interaction of the strategic road network asset. So the strategic road network asset is the main entity of Highways England, because it's the roads, the bridges, the lighting in the roads. So it's all the assets that you can find along the road. And we can see that, for example, it's impacting these 4 business areas in this diagram. Something that is important to know about the visualization, you can filter out. If you don't filter it, you will see it's really like a lot of entities, and it's quite difficult to understand it. But there is a new release. So here we can configure different filters where we can easily select the subdomain or the business area that we want to see. Okay, so now I remove the filter. So we have a big visualization of the ontology model, but by filtering it, we can have something easier and understandable. So as Ocean mentioned, we can also have the information, so the description, business areas and subdomains. Let me show you a different one. For example, if we go to model, we can also have types. So we have transport model, survey model, 3D visualization, BIM model. Why are we using this? So something important also, the ontology is a high level representation of the business flows, of the data used. It's not really in detail, because otherwise in 1 year time, it won't be useful anymore. So this is why we are using the type or the examples fields, because here we can put the different types of models that are being used in Highways England. However, if we model, for example, these types as entities, probably in 1 year time, the model is not longer updated. So that's the purpose of ontology. It's really to identify in a high level the interactions between teams, between business areas. And also, for example, if we filter on land, okay, so this is one of the business cases that Ocean explained also, land, we can also explain that the data source is GIS Redline. So this is one of the data sets that we are consuming in our new platform. So here we can indicate that this entity exists in this data model, in this data set. And then here we have a unique identifier. So this is unique in this model. We can put this information, so the land, in the conceptual data models, logical and physical data models. Like this, we can create a link from our ontology model with really our data warehouse. Okay, so let's go back to the presentation. We are almost there. We have a model. We have a lot of business areas that seem quite happy with it, but when do we finish it? Well, it depends. For a coffee machine, it seems quite easy because you have a limited type of functions. But for a company, it's difficult. It's difficult to say, yeah, it's covering 100%. So this is something that we need to define with the client to say, okay, what's the percentage of things that you want to see represented in the model? So normally, for example, for us, it was at 80%. So we can say that the 80% of business flows and interactions within Highways England are modeled in this ontology model. But for example, when we are integrating new data sets, we find new synonyms to be added, so it can always be improved. It's really something that will change and will grow in time. But at least it can now, we are really using it to build the data models, to understand how will be what will be the impact of new projects coming into our new platform. So I think that now it's really the fun. The ontology model is built and now we are really using it. So yeah, we are seeing a lot of positive values of having the ontology model. So just that's for your information. If you want to discover more about this digital transformation, there is another speak the 1st of October, I think, 1st of October, yeah, which is transport versus data. So over there, they will speak the transformation of the Highways England. So they will discuss about the ontology, all the platform used and all the changes. So it's a bit more technical speech, but it will, I mean, this is like the first step that was used for this digital transformation. Okay, so I think that this is all. This is the way we can build an ontology model. This is the different processes that we have. So just for information also, so we were a group of business analysts, data scientists building this ontology model, but BGSS is hiring all these roles. So if you are interested, please, you can check the URL that is in the slide in case you are really interested on getting on board on more data projects. And now let's jump into the questions. So let's see if we have some questions.
So there was one that came in quite early on, Ocean, when you were presenting. How is this different from graph databases? I think it was right at the start of your presentation.
Yeah, so I touched on it a bit later on, that ontologies can be used as schemas for graph databases. You can actually use a graph database to represent an ontology, but generally speaking, graph databases are databases. They hold data. So they're much lower level. You actually store the data about things in the graph database, so you can query your data. The ontology is supposed to, like Nieva said, be a bit higher level, help you structure your data rather than be an actual store of your data. So you can use your graph database to store an ontology, We didn't do this because we wanted the ontology to be easily usable by everyone in the business. We didn't want them to have to understand how to query graph databases in order to use it. So that's why we didn't use any of those tools. But you can use kind of things like any graph database tool to store an ontology.
And then the next one, Neves, came in when you were presenting. Could you comment on your experience of modelling occurrent entities and their interrelationships? These appear to be exceedingly abstract.
Yeah, it was not easy, of course. So yeah, the occurrent, in general terms for me, it was easier for me to understand. The occurrence were mainly activities. So we can have, we need to maintain a road, or we need to update a database, for example. So it's really the activities itself. So the way to connect it with the real life, with the real things, is, for example, these activities are performed by a role, or you required a system to do them, or you required material to do them. So it's really the interaction. You can really connect them with material and immaterial things based on who is doing this activity, or with which tools they are doing these activities.
And we've just got a couple more questions which can fit in. So, are there places in the model where universals are related to particulars? Open to either of you for that one.
Yeah, I'm happy to take that. So what we call entities are technically universals in ontology jargon. So yeah, what we've been talking about as entities are universals, if you're familiar with ontology language. I'm guessing what you mean by particulars are kind of like individual representations of those things. So in the ontology, you don't store data, you just store types of things that exist. So we have person as a thing that can exist, but you would never have like ocean as an employee stored in your ontology. You can put this information in your ontology. We haven't, because there are so many things in Highways England. We've just been focusing mainly on getting the structure there first, and using it to then structure our logical and physical data models, which would then store the data. But you can do that. That's one of the things that is available.
Fab. And then the last one, can machine learning help automate building of ontology?
Why are you laughing, Ocean?
As a data person, I've kind of been wondering things like this. Can it help? Yeah, I'm not entirely sure, is the honest answer. I'm sure you could find situations where it does help, but I think most of the ontology creation stuff is done by understanding the business logic and the business flows, which is difficult to get any sort of machine learning in to help you with. One thing you can do is use machine learning to help verify that your ontology is correct. So you can do things like, so we have like very specific syntax that we've decided to use to make our ontology clearer and more consistent throughout itself. And we also have to make sure that the meanings are correct. So what you could do is you can add some like maybe natural language processing to check that the definition you've given actually kind of corresponds to the definition of the word, generally speaking. It won't be perfect because, I mean, this is very domain specific, but there are things you could do. I'm not sure whether the actual effort to create the models in the first place would be more or less than the effort to actually create the ontology data.
Fab. So thank you so much, both of you. That was a really interesting talk. We have a number of other presentations going out during Leeds Digital Festival, so I will follow up after this session with a recording of the session, a curation of any of the questions that you've asked, and a link to all the events that we've got going on. So thank you so much, and hope you enjoy the rest of the festival. Take care, guys.
Thanks.
Thank you.
Bye.
Bye.